How many civilizations could exist? One. In 1961, astronomer Frank Drake sat down with a group of scientists and wrote a simple equation on a blackboard. It was designed to estimate the number of intelligent civilizations that might exist in our galaxy right now. Civilizations capable of communicating across space. The Drake equation multiplies together a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction where intelligence evolves, and how long those civilizations survive. Plug in optimistic numbers and you get millions of civilizations. Plug in pessimistic numbers and you get one, us. For decades, the equation produced more arguments than answers. But in 2026, with new data from thousands of confirmed exoplanets and updated stellar surveys, scientists are finally plugging in real numbers instead of guesses. And the results are changing everything we thought we knew. Exoplanets in the habitable zone. What we found by 2026. 20 years ago, we knew of almost no planets outside our solar system. Today, that number has exploded beyond all expectations. As of 2026, astronomers have confirmed over 5,600 exoplanets, and among them, dozens sit in what scientists call the habitable zone, the orbital distance from a star where liquid water could exist on a planet's surface. The James Webb Space Telescope has transformed this field entirely. Webb can now analyze the atmospheres of distant planets, searching for chemical signatures: oxygen, methane, carbon dioxide, that might indicate biological processes. In 2025, Webb detected tentative hints of dimethyl sulfide in the atmosphere of exoplanet K2-18b, a molecule that on Earth is only produced by living organisms. The results sent shockwaves through the scientific community. It has not been confirmed, but it has not been ruled out either. The search just got very real. Here is the problem. The universe is 13.8 billion years old. Our galaxy alone contains over 200 billion stars. Many of those stars are billions of years older than our sun, meaning any civilization around them had a massive head start on us. Even traveling at just 1% of the speed of light, a civilization could colonize the entire Milky Way in about 10 million years. 10 million years sounds long, but it is less than 0.1% of the galaxy's age. So the question that physicist Enrico Fermi famously asked over lunch in 1950 becomes impossible to ignore. If intelligent life is common, they have had billions of years to spread across the galaxy. They should be everywhere by now. We should have heard something, seen something, detected something. But we have heard nothing, seen nothing, detected nothing. This contradiction, life should be everywhere, yet we find no evidence, is called the Fermi Paradox, and in 2026 it remains completely unsolved. The Great Filter. Are we ahead of it or behind it? Of all the proposed solutions to the Fermi Paradox, one stands above the rest in its implications and its terror. Economist Robin Hanson proposed that somewhere between simple chemistry and galaxy-spanning civilization, there exists what he called the Great Filter, a barrier so difficult to cross that almost no species ever makes it through. Something kills civilizations or prevents them from ever arising. The critical question is where that filter sits relative to us. If the Great Filter is behind us, if the incredibly rare step was the emergence of complex life, or multicellular organisms, or intelligence itself, then we may be one of the first civilizations in the galaxy, and the future is wide open. But if the Great Filter lies ahead of us, if something routinely destroys civilizations at our level of development, then our future may already be written. This is why, paradoxically, the discovery of even simple life on Mars would be one of the most terrifying findings in human history.